I'm talking about the four forces of flight. Just realized that's got four forces of flight. And so if you'll bear with me, let me draw my little airplane here. Should have left my little airplane up here a while ago. So that's my little airplane. I'm using this guy here today. This resembles my aircraft, which is I have a Cessna, which a Cessna is a high-wing aircraft, which is really nice, isn't it? Yeah. So we have an high-wing aircraft. It's my little Cessna. I got a little. I'm gonna put mine here. So one of the first forces I want to talk about is the one to give lift. So what is lift? What does lift mean? What does lift do? It makes you go up. Very good. All right, there's four different directions you can go. So lift makes us go up. So what gives us lift? What gives us lift on an airplane is a wing, and it has an airfoil. And the handout Ms. Lander gave you has a picture of an airfoil or a lip or a wing. So if you're looking at this plane sideways, you're going to look at this airfoil, this wing sideways. And so as you look at it, you know the curvature of the wing is a lot wider. This LE is for leading edge. I don't have enough room, so I'm going to abbreviate. I'll tell you it's leading edge and trailing edge. And then this little line down the middle is from the leading edge to the trailing edge right through the middle. And I put that on there because as the wind blows, I'm going to abbreviate this as well. RW is relative wind, so as you have relative wind, it hits that wing and you have a leading edge. And this wind goes over the top and the bottom of that edge. Now what happens to that wind when it hits the front of that wing, when it's front of the wing? What happens to the wind? It'll split, yeah, top and bottom. And we have an issue with the winds going on top and the winds going on bottom. And what happens here is we have different pressures. So I'm going to abbreviate again, y'all can write it out. But when the wind splits, goes on top and bottom, you create a low pressure on top because the wind's going faster. And Bernoulli's theory is that as wind goes faster, as the fluid goes faster, the pressure is lower. So as the wind goes faster, the pressure is lower. So we create a low pressure on top, and the bottom is either high pressure or it stays the same. So the top lowers the pressure. So Bernoulli's principle, which is what this first Bernoulli's theory or Bernoulli's principle is, low pressure and high pressure. And you can see they've got a better illustration than I do, is when you have low pressure and high pressure, which direction will it go? Will it go toward the low pressure or will it go toward the high pressure? It'll go toward the low pressure. It's trying to equal it out. So to equal it out, the high pressure is going to go toward the low. So we have high pressure on bottom and low on top. It's going to give lift to that wing. So that's Bernoulli's theory right there. The relative wind hits that main chord line, and it creates a pressure. It'll give lift. There's also another way to give lift. Red is my relative wind. So another way to give lift, say we're in an airplane, we're in the air flying along, And what happens if we're flying along a little airplane, what happens if I raise the nose up? What's going to happen to the plane? Is it going to keep going straight? If I raise the nose up, is it going to fall? If I raise the nose up, will it climb? Going along, what's going to happen when I raise the nose up? Do what? You're going to climb. At least you hope you're going to climb. Yeah, that's the idea. So as you raise the nose up, the wing is now the mean chord and the relative wind, the angle is increased with the mean chord and the relative wind. So you can raise it up. The wind's going to push it up. Why is it going to make it climb? Well, we have another theory in your handout. It's on the next page. On this page, at the very bottom. Whose law is that? Newton's law of motion. Every reaction has equal and opposite reaction. Newton's third law. So as the relative wind hits the bottom of that wing, that's the action, and the reaction is to give it lift. So what two forces give a wing lift? Bernoulli's principle, which is low pressure and high pressure. Bernoulli's principle, low pressure, high pressure. And Newton's third law, which action gives an equal and opposite reaction. So now we have lift. Now we're going to talk about another force. It's called drag. We have drag on an airplane or an aircraft. The faster it goes, at some point when it flies, or at some point it won't go any faster. What causes that? What causes, like, I've got the pedal limit, I'm going as fast as I can go, and that's all I can do. What's keeping it from going any faster? Yeah, it's drag. So there's two types of drag. There's an induced drag. I'll get out of the way. There's a parasite drag and an induced drag. Where the parasite drag is when you're moving along and you get to some point you can't go any faster. That's going to be the parasite drag, which is way up here. So as we go faster, the parasite drag will stop you from going any faster. Now, sitting on the ground, parasite drag is almost zero. As we increase, parasite drag increases. The other drag is induced drag. It gives, it's the shape of the wing. You know, this wing will fly faster than a round object or another object. That's the shape of the wing, or the shape to make it aerodynamic. That's what I'm looking for. So between the aerodynamic and the drag, and at some point, the induced drag and the parasite drag at a certain speed, like this particular aircraft, engineers have designed it when it reaches 100 miles an hour, you get this lowest total drag. Should say lowest. And usually it's about 100 miles an hour, this kind of aircraft. So they've designed it to when the induced drag and the parasite drag intersect at the lowest point. That makes it optimum flying time for this type of aircraft. So we want the lowest total drag to be the most efficient. So now we've covered lift, we've covered drag, and let's cover weight. So what is weight? What is weight? What causes weight? Hmm? Force of gravity, absolutely, that's a perfect textbook answer. So if you were getting in my plane and I asked you how much you weigh, and I ask how much I weigh, why am I concerned about weight when I get in an airplane?
Brings you down.
Yeah, at some certain point, you can't put any more weight on the plane because it won't fly. So we're concerned about the weight. So we've got to make sure we don't have too much weight. When we put weight on it, don't have too much. So weight in an airplane is made of the weight of the aircraft, and we call them bodies and bags. You know, how much body bags and fuel is what we refer to. How much body bags and fuel you got in your plane? So it's how much passengers weigh, how much luggage weighs, how much fuel weighs. And it's a very important factor to make sure you get the airplane off the ground if it weighs too much. So what's another element of weight? Of weight? As we're flying along, if you think about this first, as you're flying along, and I don't know if any of you have ridden a bicycle before, but as you're flying along, you make a turn. To make a turn, does the weight increase of the aircraft? You're ridden a bicycle and you're going on pretty fast on a bike. You just turn the steering wheel, or you just kind of lean into it? How are you able to just lean into it? What forces your weight? There's a centrifugal force. You ever heard of that, centrifugal force? So as you're flying along, the airplane turns, there's a force that's pulling this aircraft this way, so it should be going, whoa. But instead, you know, as the airplane turns like that. So this is called, I call it a centrifugal force, but it's called a load. So as we turn, I'll draw a little airplane here, maybe. So as my little airplane turns, this top one, as I'm flying level, my load, my weight and lift are equal, I'm okay. But as I make a turn, I have an additional pulling down a centrifugal force. So I have additional load on there. So I have weight, we'll just call this load. Some people are loading up the aircraft. So if I turn, at some point, you know, I can't turn anymore because it's going to drop out of the sky. But as I turn the G-force, you ever heard of G-force or gravity? You're sitting still, everybody's got a G1. As you go up, you have centrifugal force. You can be a G2 or G3, and you've heard of, you know, strain lead G9s, you know, 9 Gs or 6 Gs. Well, 2 Gs is 60-degree bank. So if I'm at 60 degrees, that's 2 Gs. That's twice your weight. So we can weigh the aircraft down with 2 Gs. So the opposite of weight is lift. So if I'm turning and I have 2 Gs, I've got to be able to create 2 Gs of lift. They're just the opposite. So now we've covered lift, we've covered drag, covered weight. What's the other one? Any idea? Good. Yeah, it's thrust. So what's on the front of this aircraft? What's this little bitty thing up here? How does that propeller make the plane go? How does it create thrust? It goes round and round, right?
Good morning.
If you look at the side of this prop or this propeller, This is a profile of the propeller. Have you ever looked at a prop up real close to see how it looks? It's shaped kind of funny. Well, this shape is similar to another shape. What is that? Yeah, it's an airfoil. The prop is really an airfoil. So the prop also has what's called a mean chord. And the wind is from another direction. We have a vertical wind. So this prop is like a wing up here that we talked about, has a main chord in relation to the vertical wind. And we also have Bernoulli's effect on the prop. We have a low pressure and high pressure on the prop. So which do you think is low pressure, which do you think is a high pressure? Is the low pressure going to be on this side of the prop? I'm going to put P for pressure. This is your prop. Think about the wing. And you're going this way. Which is the low pressure? Which is the high pressure? We're creating lifts, so we're doing lift in a vertical plane. You know, we lift is straight up here, but now we're doing lift horizontally. So this is going to be low pressure, and this is going to be, yeah. So now you got low pressure and high pressure, just like this wing up here. So as that prop spins, it creates lift through its curvature of the wing as well. So what are the four forces of flight? Yeah, lift, drag, weight, and thrust. So how do they interact with each other? So what's the opposite of lift? What? What's the opposite of thrust? So we have so much thrust. When do we quit flying? When do we quit speeding up? When drag is equal to thrust. We can keep increasing because it's all about going fast in airplanes. It's all about going fast for rockets. But at some point you quit going fast. You want to go fast, and at some point you just kind of stay the same speed. So what speed you quit going fast? It's when thrust and drag are equal. Okay? So if I say, what's my airplane doing when thrust and drag are equal? Am I going faster, staying the same, or slowing down? Stay the same. Very good. So lift and weight. What happens if I'm sitting on the ground? Is thrust and weight equal when I'm sitting on the ground? Yeah, they're equal. What happens if I'm climbing? Which one's lift is greater? I'm climbing. What happens when I'm descending? What happens when I'm just traveling along and I'm staying the same altitude? Lift and weight are equal. Man, you guys have got this. This is one of the hardest principles people have to understand when I say, when lift and weight are equal, and thrust and drag are equal, can I still be flying in the air? Yeah, because you have all equal elements, everything's the same. But when I increase the load, say I make a turn, what's going to happen to that plane? What should happen to that plane? As I increase the load, it's going to go down. Yeah. And so the next other classes we teach is what happens when you make a turn. And the students always has trouble. Well, the plane should stay at the same altitude and turn. Well, no. It's going to, as soon as you turn, what's this plane going to do? It's going to start dropping. Oh, man, Carl, these guys are good.
I
Because
told you
we got
they'd
some
talk to
pilots
you.
we got pilots that don't understand that. Well, I just turn it and it should stay the same. Well, no. You're increasing the lift because it's almost twice the lift. So as you turn, that nose goes down every time. And so in a sense, you have to counter it. You have to raise the wing to create more lift. Raise the wing, create more lift, then make your turn, and it'll stay the same. So, absolutely. You guys are good, y'all got the whole deal. So lift, weight, drag, and thrust. Hey, well, I'm good here, Carla.
You're better and better.
I mean, I'm done here, I'm good.
Oh,
Any questions? I mean, I'm gonna figure this out quick.